every day you and I get bombarded with negative news. Just like the body becomes what we eat, the mind becomes what we're putting in. It is important to listen to stories that not only gives you hope, but also inspires you and uplifts you. In this podcast, we're interviewing experts who will break down the solutions to the world's most pressing problems. And I promise you, if you listen to this podcast, you will not only stay informed, but you will also feel more energy in your life. Welcome to Great.com Talks with. Great.com is a philanthropic project where we're donating 100% of the profit towards the most effective cause areas like protecting the rainforests and funding climate change technology. And the topic of today is tropical storms and global warming. And to understand more about this, we have invited Dr. Tom Knutson. Tom is a senior scientist at GFDL at the Weather and Climate Dynamic Division. And GFDL is a part of NOAA, which is the National Oceanic and Atmospheric Administration, which is also part of the American government. And one of Dr. Tom's focus areas are tropical cyclones and climate change. And in this interview today, we're going to talk about how tropical storms has been affected by global warming. So, Tom, welcome to this interview.
Thank you. It's good to be here.
Tom, if we start by just understanding GFDL, what is that, and what is the kind of research that you're doing, and why is that research important?
Well, GFDL stands for the Geophysical Fluid Dynamics Laboratory, which is a research laboratory within NOAA. And at GFDL, we do a lot of climate modeling, also some weather modeling. And we also look at observations and compare observations to our models. But we're making, among other things, predictions and projections for how climate is expected to change in the coming decades as we continue to have a buildup of greenhouse gases in the Earth's atmosphere. In other words, global warming. So we're looking not just at how greenhouse gases affect temperatures, but also how it affects other things like hurricanes.
So I guess to be able to make good decisions is crucial to have this data. And how far back in history have we been tracking kind of tropical storms related to climate change?
Well, our records of tropical storm activity extend back even into the 1800s, especially when we're talking about landfalling, say U.S. landfalling or Northeast Australian landfalling hurricanes or tropical cyclones. And in fact, information on hurricanes extends back even further if you go back into documentary records, newspaper reports and things like that from the Caribbean. And geologists can even extend the record back even further by looking at sediments in near coastal lakes and things like that. Thousands of years they can go back and get some idea of what tropical cyclone activity has been like over much longer periods in these particular locations where we have these sort of geological proxy records of storms.
So I'm hearing that we have a lot of data to see different kind of effects throughout time. How would you say?
We have a lot of data, but we also have a lot of data problems too. We wish we had a lot better data and long records, but we have some data that looks at some aspects of tropical cyclone activity going way back, but we don't have anywhere near the kind of observational data that we would like to have to look at this problem.
That's a perspective that I would not have thought of. So interesting to say that we need much, much more. And I guess my next question is going to be a big one, which can go in different directions. But how would you say that the tropical storms has been affected by global warming?
Well, I think the clearest effect is through the impact of sea level rise. Because sea level has been rising, whatever storm activity is going on is happening on a higher background sea level than it was, say, in 1900. So that is causing some additional impacts of the hurricanes because the inundation levels are increasing also in coastal regions when we have a hurricane that strikes land with a storm surge and so forth. So that's the simplest link. When we look at hurricane activity, you can look at different aspects of it. For example, are the storms getting stronger or weaker? Are they getting bigger or smaller? How about the rainfall from the storms? How about their frequency? So there are many, and their duration, and what of areas over the Earth they're affecting. So there are many different questions we can ask about hurricanes and climate change. And the most confident statements we can make, especially in terms of future projections, the most confident statements that we're making presently are that we expect that hurricanes are going to have higher rainfall rates in the warmer climate because the atmosphere is holding more moisture, and a hurricane sort of acts like an engine to converge that moisture in toward the center of the storm. And when we have global warming and more moisture in the atmosphere, that can lead to higher rainfall rates in the storms. We also expect that global warming is probably going to lead to higher intensity of storms. The magnitude of that change we expect to be something like 5%, a 5% increase in wind speed intensity over the coming century. So that's not a huge change, and it's difficult to find a change such as that looking in the past data, which is something that we're looking for very carefully. I spoke about future changes that we expect from hurricanes, including increasing rainfall rates and increasing intensity, and in fact, an increase in the fraction of storms that reach these higher categories, like category 3, 4, and 5. Those are future projections. We don't have as much to say about the total frequency of storms. That's something that's still has a great deal of uncertainty. Now, one issue that comes up, though, is have we actually seen these changes in the data? Have we identified a human sort of fingerprint in hurricane activity? And that gets to be a tricky question. Clearly, we've identified a human impact on, say, global mean temperature because the signal is so strong in the data, and we're able to model the signal very successfully with our climate models and identify this anthropogenic signal. However, for hurricane activity, it's much, much harder to identify a human influence in the past data. And I can go into that in much more detail. But for example, if you look at just the longest record we have of landfalling hurricanes for the U.S., say going back to into the late 1800s, and just count the number of hurricanes or major hurricanes hitting land in the U.S., it's flat. There's no real change over this century timescale, despite the fact that we've had global warming going on. So, if we want to look for something like the change in rainfall rates or the change of intensity, then our data sets are not, they don't go back as far, especially if we're looking at, say, intensity of storms out over the open ocean and so forth. We have some problems with data, so we can only really push the data back to around 1980 or so for intensity and use a satellite record to see whether we're seeing changes. So that's only about 40 years in that record. And that record is beginning to show some signs of an emerging increase and an emerging shift of storms toward the higher categories. But the change that we're seeing is not as large as and as well-defined as what we see for global mean temperature, where we can go back much further. We can go more than 100 years back and see that signal emerging. So that's what I was referring to earlier when I said I wish we had more data. I wish we had a perfect record of tropical cyclone intensities that was global in nature and it extended back to, say, 1900. But we don't have that record. We sort of have to address this problem with what we have, which is a much shorter satellite-based record that starts around 1980 and goes forward from that.
So you're saying that right now we have future projections that the storms would increase in intensity with 5% and probably have more rainfall. So what does that mean when it comes to, should that be something that we were concerned about, that there's more rainfall coming? I guess intensities, that seems like a bad thing, but is it bad when more rainfall comes? How should we understand this?
It can be bad. It sort of depends. I mean, some areas depend on tropical cyclones for their water supply. So they do contribute to the overall precipitation that some areas experience. However, we can also have very damaging flooding rains associated with tropical cyclones. For example, Hurricane Harvey in the Houston area a few years ago caused a tremendous amount of damage just from the rainfall, because the storm stalled out in the Houston area and lasted there for several days, and creating a real disaster in terms of flooding there. So it really depends, but clearly tropical cyclones have a great potential to inflict a lot of damage through rainfall. And also, of course, through the storm surge flooding. So, for example, when we had Hurricane Katrina hitting the U.S. Gulf Coast in 2005, caused tremendous damage from the storm surge associated with Katrina coming in off the Gulf. So, impacts from hurricanes can come from a lot of sources, but getting back to your question, rainfall out of the storms is an important component of risk from tropical cyclones.
To give some context when it comes to tropical storms, that they have different degrees in intensity. We're talking about level 1, 2, 3, 4, 5. Is that the scale?
That's right. And category 1 refers to a sort of a minimal hurricane. But tropical storm is even weaker than that. So you might call that maybe a category 0 or something. So the tropical storm is the weakest form. And then we go to, once we get to hurricane, then you have these 5 levels, the so-called Saffir-Simpson scale, which goes from sort of minimal hurricane all the way up to the catastrophic level, category 5.
They make quite an impact when they come, make a lot of news kind of attention, like Katarina. So could you help us just mention some of the storms or hurricanes that we've seen and help us to categorize what kind of scale are they on, those that people would recognize?
Well, say Hurricane Katrina that I mentioned earlier was a category 5 storm out over the Gulf of Mexico, which actually weakened. I believe it was a category 3 when it made landfall, but it was so strong out over the Gulf that it kind of put all this energy into the ocean. And when it did come in and made landfall, it was carrying this, driving this quite large storm surge, which was as high, as I understand the water levels were as high as close to 30 feet above land there in the sort of epicenter of where Katrina landed. So, we have famous storms in the U.S., such as the Galveston hurricane, which caused, say, 11,000 deaths or so in the early 1900s. You also have storms internationally, for example, in Bangladesh and Myanmar and places like that, which have been hit by tropical cyclones, which have caused hundreds of thousands of deaths in some cases. So these tropical cyclones, especially when they hit sort of less developed regions, regions where people are living in more vulnerable locations, can really produce very great humanitarian disasters. And tropical Haiyan in the Philippines is another example, which killed several thousand people just a few years ago. So these can be very devastating events, particularly in the more vulnerable parts of the world to these types of events.
So I'm hearing, but we both need to look at the intensity scale and also how well prepared we are, each city or each location, how well prepared they are for a storm.
That's right. That's part of it. And also we need to be concerned about more than just the intensity, because sometimes even a storm which may not be particularly intense may still be quite dangerous if it has a very large wind field and can generate a large storm surge. Sandy, for example, Hurricane Sandy, which was sort of transitioned to an extratropical storm before it made landfall in the U.S., but that was not a particularly strong or intense storm at landfall, but it had a very large, extensive wind field and was able to generate, because of its sheer size and its angle of approach and so forth, a damaging storm surge along the U.S. coast. So we have to think about these hurricanes as having multiple dimensions of risk. Risk from the storm surge, risk from the intensity, which is, we're talking about the winds of the storm, and also risk from flooding rainfall, for example. So there are multiple dimensions of risk to be concerned about. And some storms, like some hurricanes like Hurricane Andrew, which hit Florida in the early 1990s, are primarily wind events. They don't have much of a storm surge impact. Other events like Sandy and Katrina have larger sort of storm surge impacts. And then still other storms have their main impact through flooding rainfall. And we have examples of those both in the U.S. and Central America and in Taiwan and all sorts of places, of examples of flooding rainfall problems from tropical cyclones.
Okay, that helps to understand how to view the storms. It's not just intensity; it's also their special effects, almost like they have superpowers in a bad way. So, if we go into the climate models, the way I understand it, we measure the tropical storms and hurricanes, cyclones, so that we then get data to add into the climate models. And then we want to project the future. And you're saying that there are multiple problems when we're trying to do that. Have I understood how this works? And what are those problems?
Well, we might take a couple of different approaches here. First, we can look at the past data to see if we actually see trends emerging in various tropical cyclone measures. Trends like we see, for example, with global mean temperature. So let's look for these same types of trends in the historical data, and we're doing that. That's one sort of approach that we're taking. But we can also try to use our climate models to simulate how hurricanes will behave under warmer climate conditions. So to do that, we want to take these models and demonstrate that they can actually simulate hurricane activity like we see in the present climate. And so we've made a lot of progress in that area with our models. Now we can simulate year-to-year changes in storm numbers pretty reasonably for the Atlantic Basin, for example, if we know the sea surface temperatures, differences between those years. And models, the models have a limited ability to simulate the most intense hurricanes and tropical cyclones because of the limited resolution in these models, the degree to which we can kind of focus in on just a small part of the globe and simulate the hurricane. So with our current generation of climate models, what we're really able to simulate in the main simulations are just sort of weak cousins of the real thing. They don't get to be sort of category 5 or anything. They tend to be a little bit broader than they should be and weaker than they should be. So nonetheless, we can see how those phenomena behave in climate models in our global warming experiments. And we can use other methods, like try to use specialized models to try to hone in and simulate these storms, future storms, with higher resolution. So what we're trying to do is use our models to sort of peek into the future and see how, according to the models, the hurricanes are going to behave under conditions that we really don't experience now. So what the climate models are saying in terms of global warming is that we're going toward conditions which are outside the range of our present day experience. The tropical oceans will be warmer than at any point in human history. So the question is, what's that going to do to hurricanes, since hurricanes are a type of storm that develops over warm tropical ocean surfaces. So we know hurricanes sort of like warm tropical oceans. What happens if you sort of juice up the tropical ocean temperatures, and what happens to these storms? That's the kind of question we're asking when we do these future model projections. But we shouldn't treat these future projections as absolute truth. They are indicators from the climate model of what we think the behavior is going to be. And so that goes back to the question I mentioned earlier, is what kind of changes are we actually seeing so far in the data, because the tropical oceans have already been warming more than a half degree Celsius in many of these tropical storm regions. So that's why we're looking at the past data too, to sort of see how things are evolving, both in the historical record as well as how they're evolving in these climate simulations for the future.
As you are doing this research and you're projecting the future, what happens with this data and this research that you do at GFDL?
Well, it becomes, we publish our results in peer-reviewed literature. So we have to show that to our colleagues that we've done a credible job of with our papers and with our model simulations, and that we are making reasonable conclusions about these results. And then another activity that goes on is in the sciences is we assess the whole field. So we look at all sorts of publications that are coming out on this topic, and we try to summarize what the state of the science is. What is the basic message that's emerging from this body of science at this point? So we do what's called a scientific assessment. And I've led a couple of these that looked at tropical cyclones and climate change, where we tried to look at the field as a whole. So we're looking at many studies that look at observational evidence, many studies that look at, that try to do modeling of tropical cyclones and so forth. And we try to look for things like, how much consistency is there between the use of different models? How good is the physical understanding of what's going on? How well do we actually understand the physical mechanisms involved? And how strong are the signals we're seeing in observations? Are they very strong, like the case for global mean temperature? Or are they virtually absent, like we see for the U.S. landfalling hurricane record? So we're trying to assess all the evidence, and then we come up with statements, like example of a statement may be that we now have medium to high confidence that tropical cyclones are going to be more intense in the coming century. So that's a statement saying this is how much confidence we have in that projection based on all the evidence that we looked at. And notice that we're not stating it as a fact. We're not saying that this will happen. We're saying that we have medium to high confidence that this change is going to happen. And the same when we're looking at past observations. If we look at some observations that say that the fraction of storms globally that reach category 3 or higher, that fraction is increasing over time. We can say that the data show this, but how do we interpret it? Is that a change which has been caused by human caused climate change or not? And so in this case, We have some examples in our assessments. For example, we say there's low to medium confidence now that the latitude at which tropical cyclones reach their maximum intensity has migrated poleward over the past since the 1940s. That's an example of a statement that we make based on the observational evidence. And so we haven't actually assessed the one about the category 3 to 5 tropical cyclone fraction yet. That was a paper that came out after our last assessment. But when papers do come out with new results, then we consider them and try to make some judgment as to how confident we are in some general sense about this being, is this change we're seeing something which is clearly unusual compared to natural variability, or is it something which is sort of, could just be explained by natural variability because it's really not much different in character than natural variations as we estimate them.
If I look into a societal kind of perspective, I guess you would bring forth the evidence with confidence scale on how likely something is to occur, and then the politicians would need to make decisions based on that. And I'm guessing there would be a gap here where you know a lot of things, and then it's hard to translate that into other people who's they're expert at other things. But then would you say that there are, how long time does it take until you might publish this science until it actually comes into anything meaningful in society where we can actually use that data? Is that even a question that you can answer?
Well, I think that once you have the peer-reviewed science paper, I think that's a good. That's something that policymakers and others can consider, I think, when they're thinking about the problems. But I think that this assessment process, and let me just sort of make a little plug for the IPCC, the Intergovernmental Panel on Climate Change. So they come out about every 6 years with an assessment of global climate change. And really, they try to assess the evidence on not just hurricanes and climate change, but all sorts of climate change issues. And they try to create what's called a summary for policymakers right at the beginning of the report, which is about 30 pages long. I mean, the report itself is a couple thousand pages maybe, but there's a 30-page, say, summary at the beginning, which is really targeted at policymakers, where we try to, the report authors try to put the science into a perspective that educated sort of high school or college educated person can understand. You don't have to be an expert in the field to, I think, to grasp the meaning of what they're saying in the IPCC summary for policymakers. And that is the way that science is trying to communicate to the non-scientific community, including policymakers, putting things into a form that's understandable, but yet still scientifically robust and scientifically credible. So it's kind of a delicate balance to make. You know, you want to make things credible and scientifically credible, yet you want it to be understandable to people who need to use the information for decision making. But I think that IPCC does a good job with this overall, and that's what we've aimed for too in the assessments we've made for just tropical cyclone and climate change that I've led. These were not IPCC assessments; these were ones commissioned by the World Meteorological Organization. But in doing our assessments, we did try to boil things down to a form where we thought that it could be useful to the public. And by the way, we in doing so, when we did our last tropical cyclone climate change assessment, we realized that in doing these assessments, we often have biases as scientists. So one can either look at evidence and say, well, I want to be very careful here. I don't want to overstate what the impact is of humans on climate. So I'm going to require pretty high standards of evidence before I draw some conclusion. we may call that trying to avoid a type 1 error. On the other hand, we could come at it, the whole problem from a different perspective. We could say, look, I'm not so concerned about whether I overstate the problem, but I don't want to understate the problem. I don't want to overlook a human influence that's happening on tropical cyclones. So if you restate the goal in that way, then you come up with, well, we have a lot more studies here that now are showing some possible human influence on tropical cyclones. We don't think that we can be very confident about them from sort of this original way of looking at things. But if you turn the question around and you're trying to avoid overlooking something, then okay, well, we have a whole bunch of studies where there's possibly some human influence emerging in the spirit of not overlooking things. So that's a question then of what does the audience want? You know, which perspective do they prefer? So we tried to actually present both so that they could choose, but also sort of make explicit what our biases, our underlying kind of goal was in doing the assessment. So anyway, it's difficult issue, I think, trying to communicate effectively between the sort of the science world and the users of this information.
Let me make an analogy to what you just said there and see if this makes sense. So back in a couple of thousand years ago when there were villages, let's say one human went out of the village and saw 10 wolves coming, hungry wolves trying to come for the village. Then this human runs back to the village and either shouting, hey, there's 100 wolves coming, overstating, or hey, there's one wolf coming. You're saying that in science, you need to be careful to not overstate 100, not understate either, only one, because that's going to affect how much action we take on it. And you did a study, which one is actually the most harmful, or have you even been able to figure that out, or if does that resonate, that image of a wolf?
Yes. Well, we're just trying to provide as rigorous, balanced, useful scientific information as possible. And we thought that even admitting that the framing of how we present information was important, that we might even try looking at the information presentation using two different framings of the problem, and that being which kind of error are we trying to avoid, which type of mistake is more consequential, and maybe it depends on the particular audience that wishes to use the information. And I'm sure there are analogies sort of in medicine and things like that, but we were just trying to use this approach in communicating the current state of science about hurricanes and climate change, which is a very, it's one of these topics where it's not all cut and dry. There's still a lot of research being done. There's still some controversy about how to interpret things, how confident to be in certain things. There are lots of problems in the data sets. So someone may publish something using a data set which we don't have much confidence in. So, so there are plenty of issues running around the problem, and it can be a bit complicated. But we're trying to sort of boil it down to what we think the overall assessment is at this point. That's what we're trying to do with these assessments.
Very, very helpful to understand that the politicians would get the summary to make it as easy as possible to understand. I see that as, I guess, an answer to my question. Well, what happens with the research in the end? How do society use this? I was thinking that we're going towards the end here in this interview, and I want to make sure that when it comes to tropical storms or hurricanes, is there other things that we not talked about that you think is important to address?
Well, we talked about sea level rise. We talked about intensification of storms. We talked about rainfall rates of storms increasing, and we talked about the difficulties of saying anything about frequency. And that goes, I think, too, for changes in areas affected by these storms. There are lots of examples of strong multi-decadal variations going on, especially in the Atlantic Basin, which make it harder to identify long-term trends. I participated in a study where we showed that storms are tending to intensify. They're more rapid intensifiers now than they were in 1980. But we're still not sure that change we're seeing is outside of natural variability. So it's still an evolving science, and we're doing what we can to improve scientific information on it, both looking at the past data and using our models to look at the future. Our models are getting better, by the way. As we get more computing power, we can use models which have finer scales, and can sort of zoom in more closely and simulate more realistic hurricane structure. So I think we're on the right path. We're still trying to learn and continue learning about the problem and relate what we're learning then on to society at large, and also to policymakers. So hopefully this has been helpful in sort of showing what we're trying to do, what the aim is of some of these activities, such as our assessment activities, as well as our basic research.
It has. I think this breaks down just hearing that a tropical storm is not even on the scale of the 1 to 5 scale. I think that might be interesting to understand, because all the information as a normal citizen, I'm just hearing about the tropical 3 to 3, 4, 5 storms. So understanding that they have different, they affect society differently, different storms, and that they have different implications. It's interesting to hear. I'll be happy to kind of leave it at that. If you would direct people who are curious to understand more about tropical storms, what would you recommend people to look?
Well, they can visit my website I have off of my homepage, which I think you can get to just by Googling global warming and hurricanes. There is a NOAA website which they can go to, where we try to go into this in a little bit more detail, and also we have links to these latest assessments that we did, which I think are people should be able to download. And in general, when people are interested about not just hurricanes and climate change, but climate change in general and different types of extremes, then there are a couple of sources which are very good, which including the IPCC reports, Intergovernmental Panel on Climate Change, as well as the U.S. National Assessment. I worked on the fourth U.S. National Assessment. So these are things which are available on the web, and are examples of these assessment products, which I think would be, for people who are interested, more interested in the subject, can look at some of these assessments, not at the whole 1,000 pages, but look at the summaries at the beginning, and these can, I think, provide some well-vetted, useful context on these many different aspects of climate change. Because that's maybe a message here, is that even when we have global warming, it doesn't necessarily mean that everything is changing in any dramatic way. So what we're trying to do is understand how different things are changing. We shouldn't assume that every extreme event that we see is somehow strongly linked to global warming. That requires a lot of analysis and looking at long records of such that type of event or similar types of events. But this is what we're doing in climate science, is trying to differentiate these some aspects which we have very high confidence in, for example, continued future warming over the coming century, and continued increases in sea level and things like that, versus things where we're still, we have less confidence or varying degrees of confidence as we try to relay on a phenomenon by phenomenon basis in these climate change assessments.